Hello, everyone. So I decided to record this personally because I couldn't find a video. There are tons of video on YouTube, but I couldn't find one that actually explained the way I wanted to explain to you ladies. Okay, so that's why I'm recording this myself. So now this is how we set up or get started with Tinkercad and then the other one which is Wokwi. Okay, so for those of you that have not created the account because of network issues on Saturday, so please, I believe you should have done that by now already. And if you have not, please do. And then after you have your account created, make sure you join the class with the class code. Okay, so here is the class Rubis GTB robotics, and then I have I think 7 students only. So those of you that have not joined yet, please do. Okay, this is the class code if you don't have it. So just once you register, once you open a personal account, you are creating a personal account, then join a class, then it will ask you for the class code or whatever. So copy this code and then you're there already. Okay, so please do that. Now I would be making a project here, so to show us how to, for those of us that are not familiar with Tinkercad, so how to find our way around, how to build circuits, write the codes for the circuits, and how to use Tinkercad generally. Okay, so I'll be creating a project, the same thing we did on Saturday, the traffic light system we built on Tinkercad on Saturday. I'll be doing the same here. Okay, so I would normally have done this, but this I want everyone to replicate exactly what I'm doing here. Everyone should do it. So this is the second assignment. This is virtually the second assignment. So once you do it, you are submitting under the class. All right. So I'll be seeing them. Okay. So all you have to do is to once you join the class, go to go into the class and make up your project inside that class. Okay. I wouldn't be doing this here because I don't want you people to copy, because if I do this here, what if you come down to activities here, if I create this project I'm about to create right here, everybody will just be able to copy it and like copy and tinker. But I don't want us to do that. I want us to do it by ourselves. So watch the video and replicate what I am doing in the video. So yeah, the reason why is because the best way to learn is to actually do, not to see. Okay, so that's it. So I'll create this project outside of the class, not inside the class. Remember, I don't want you to copy it. I want you to do it. So I'll be create circuit. Okay, that's what you do. Inside the class, you are also we are creating the circuit. Okay. So now once you do that, it opens the platform where you can build your circuit. Sorry, network is kind of. So now here is it. So once you create a new project, you have this empty workspace at the center, and then by your right you have these components, and you can see some of the components I showed you all. You can see them here. You can see a resistor, an LED, a push button switch, a potentiometer, and so many other ones that you all saw on Saturday. So this place right here is where you grab a component into your workspace. Okay, so once you create a project, you can give your project a name here. So I want to call it a traffic lights, and then click on enter. All right, so here copy paste, and these are things that we'll talk about soon. So now here is the search bar. You can search for a component you're looking for. In case you're not seeing it here, you can just search for it. And here is the category, a categorical arrangement of components. So the first thing you want to grab out here is an Arduino board. All right, search for Arduino, and then you have it. So how do you drag out? You do a left click. While left clicking, you drag. Okay, so that's it. So that's how you pull out a component from the component menu. So you can zoom in this workspace, you can zoom out and zoom in, okay, depending on how big the circuit is. So you might need to zoom in or zoom out to see what you're doing, or to look at other components that are probably hiding somewhere. Okay, so if you have an external mouse, it will be easy. But if you don't have that, you can just centralize your workspace with this. Once you click here, zoom to fit, then everything comes to the center. Okay. So I think there's a shortcut for those of you that don't have an external mouse. I think there's a shortcut for actually zooming. Or okay, maybe not. I think your mouse trackpad should will help you with that. Okay, so we have an Arduino board. Now, remember we're making a traffic light system. So let's grab LEDs. Sorry, let me take this off. We saw an LED right in the front page. Okay, so this is an LED. So I'll do, let's click and drag. I need three LEDs, right? So I'm dragging out this same LED three times. Okay, so now you'll notice something when you drag out a component. I'm still holding my left click. Once you release your left click button, then this shows up telling you the name and the maybe another parameter. Okay, so for now an LED, now it's labeling this particular LED L name 3. Okay, the name does not matter, but if you want probably to for easy identification, this first one is LED 1, second one is LED 2, this one is 3. Okay, so now you can see there is a menu to change the color of the LED here. So this happens to almost any component you grab out. So if I click on Arduino, you see it's gonna show me the name, but there's no parameter to change for Arduino. But for some components, when you click on them, it's gonna show you their name and the things, other things that you can change about that component. So for an LED, you can change the color. So we want a red, green, and then a yellow LED. Okay, so this is red already. Let's leave that. Let's change this one to yellow. Yeah, so that's it. Ah, is this yellow? I don't like that. Does this look like a yellow? The orange. Oh, okay. Yellow. Let's leave it in yellow. Then this one we want to change it to green. Okay, so now we have our LEDs. All right, so you would remember in the last class, I told you that these are digital pins. Digital pin can be an input or act as an output, and you can use any of these pins. Okay, you can use any of them. So they can be an input or an output. So for this case now, because we are controlling these LEDs, okay, the pins we'll be using must be acting as an output pin because they want to what, power up this LED. They want to give out a signal. Okay, so the pins we'll be using on the Arduino board will be acting as an output pin. All right, so if you remember again on Saturday, I say there is a component called resistor. Okay, now I told you what this thing does is to limit the amount of current flowing through an LED or anything. All right, so it limits the amount of current flowing through the LED. So the project we did on Saturday, we didn't use a resistor at all. Why? Because we connected an LED directly to one of the pin, and some of you complained that the LED was so bright, and I said yes, it is supposed to be so because we don't have a resistor connected to it. Okay, so, and then if you are doing that, the reason why the LED did not get burnt out was because the Arduino board supplies a limited amount of current to the devices connected to it. So always use a resistor with an LED. So what we did on Saturday was just an introductory class, a very quick one. All right, that was why we didn't use um a resistor. So in coming class, you go in depth into that. All right, so we'll be using a resistor here, and in fact each LED will have its own resistor. Okay, so now again, an LED is a two terminal device. Okay, there are two legs here, and they are not the same. They have meanings. One is a positive leg, and the other one is a negative leg. We are all familiar with that. Okay, so if you hover over here, you will say this is called anode, and if you look here, it's called cathode. And physically, an LED physically, just like I told you guys on Saturday, the one that has a longer leg is the positive um leg, while the other one that the other leg that is shorter is the negative leg. So on Tinkercad here, if you hover here, this one is the anode, which is the positive, and you can see the positive one is always curved, while the negative one is looking straight. So now we'll be wiring them to the Arduino board. So now what pin do we want to use? Okay, here I'll be using pin 0, 1, and 2. So pin 0 for red LED, pin 1 for the yellow LED, and then pin 3 to control the green LED. So now this is what I'm gonna do. Remember I say here we must use a resistor. Okay, so now I'll be connecting my resistor through the LED. I wouldn't be connecting the LED directly to the pin. Okay, that's what we did on Saturday, which I said is wrong, but we just did that because it was a very quick introduction. Okay, we wouldn't be doing this, we wouldn't be connecting the LED directly to the pin. Okay, because if you do that physically, when we start doing these things physically, um the LED is going to burn out because a lot of power will go through the LED. The LED will get very, very bright and then it will eventually burn. Okay, so let's delete this. Okay, so we'll be wiring this through a resistor. So let's grab this resistor right here. So now the first thing to do is that you want to change the value of this resistance. Okay, I'll explain that in the coming class. So if you click on the resistor, this comes the name and then the resistance. Now this is the amount of resistance that this resistor will provide. Okay, it is just the resistivity of the resistor. So you want to come here, it is currently in kilo ohms, you want to change it to this one, ohms. All right, then change 1 to 220. We'll be using that value, 220 ohms. Okay, so now how do you wire things up? This is how you do it. Hover on top of the pin, click on it, then the wire is going to come out. All you just have to do is to drag. When you get to your destination, do another click. Okay, so can you see that I have this leg, this LED connected to this resistor? Okay, so now I need to connect the other end of the resistor, which is this one, to the pin that will control the LED. So the resistor is just basically staying in between the pin and then the LED. Okay, so I'll click here and then come to pin 0 and make my connection. So I have that connection completed already. All right, so what will happen to this other leg? Of course, it is going to be connected to the negative terminal. Okay, and what is the negative terminal of the Arduino board? It is the port or the pin named GND. GND stands for ground. So whenever you see this thing on any hardware, or whenever you see GND labeled on any hardware, be it an Arduino board or any sensor or anything, just know that it is the negative terminal of that device. Okay, so we are connecting this guy right here. We want to connect it to um the ground. I want to make this wiring as neat as possible, so I'll just make a route this way, and then I'll go this way, and then I'll click again to make a curve, and then now I have that LED connected. Okay, so now what I want to do now is I want to connect these other ones. Remember, we need resistors. Okay, so what can just do is to copy. Look at this. Instead of me grabbing another resistor, dragging it out, changing its resistance, all I can just do is to click here, then make a copy, and then paste. Then, can you see? I have the same resistor with the same resistance. Okay, the same thing here. Okay, so for now, let me just delete this one. Let me delete this one so that it doesn't confuse my wiring right here. So let me connect the positive of this, hold on, the positive of this to this one, then this side goes to pin 1. Okay, so I'm taking this one also, I'll copy, paste. Okay, now doing this here, and this one goes right there. Okay, so my wiring is not looking very neat. Okay, so you can make a movement, some sort of movement to make your things look uh quite uh neater. Okay, okay, okay. Okay, well, irrespective, the arrangement does not matter. What matters is making the correct connection here. The arrangement does not really matter. But for neatness, you can just arrange them in a very good way. Okay, so, oh, I said I'm using pin 2 for this one, but I have it connected to pin 3. So what you can do to delete a piece of wire, click on that wire and then hit on the delete button or come here and click on delete. Okay, and you can remake that connection. Good. So now I have all the positive terminals of the LED connected to the respective pins through the resistor. Now I have the negative terminals. They are not connected yet. So what do I do? So let's start from here. I grab these. Let's just okay, let's just make our connection however we wanna do it. But when we start using a breadboard, things will get quite more neat. So all of these negative terminals are going to be connected here. So don't get confused. Don't get confused by the wiring. Okay, don't get confused by the wiring. Just understand what I'm doing, and that's it. So you can have the colors of your wire changed. So because these are all green wire, so you can have them changed so that you know what wire is what. Okay, so ground, most times the wire for ground is usually black in color. So if you change the color of the wire, so just click here and click on the color, then you have that change. So the wires for ground are usually black. So I'm changing these ones to black. Okay, so for my resistor, sorry, for my LEDs, the positive side, I can change the color of the wire to match the color of the LED. Okay, easy, right? Oh, sorry, this should be yellow. Yes, and this should be green. Interesting. So let's change for this also. Red, yellow, and green. Great. So now we have our circuit completed, but this thing will not do anything. So now once you have your circuit completed and you have your code written, what you should do is you just hit on the start simulation to have your project start working. But if I click on start, I don't think anything will happen. In fact, nothing would happen. Why? Because we have not programmed this thing yet. Okay, so the L once notice the Arduino board is on and there's an LED blinking here, but these ones are not working the way we expect them to work. Okay, so how do we make them work? Of course, that's where the coding part comes in. So if you look at here, you see code. So now on Tinkercad, you can code in, you can use visual programming, but we are not using visual programming. Okay, we are going to be using the code, the text. So once you get in code, come to blocks, change it to text, and then click continue. So here is how we do our thing. Okay, so now here, right here, there are two functions, just like I explained to you guys, to you girls. Two functions, setup, and then we have loop. Okay, so we want to delete the codes in the setup and then in the loop. So you are leaving the functions right where they are. Don't touch the setup. You can see a bracket, the curly bracing bracket open and close. That's those brackets are for these functions. Okay, you can delete the code inside of it. Okay, because we don't need that one. Then the loop function, you can delete the code inside these two brackets. Okay, so take this off. Okay, so now we now have a comment. Remember, how do you comment in C++? You do a double forward slash and then write your code. So these are basically comments. Okay, so in your setup, This is what you want to do. Remember, the pins that will control this LED has to be an output pin. Okay, so we want to set those pin as an output pin. So the first thing to do is to set this pin as output pin. So we have what pins? Pin 0, pin 1, pin 2. So how do you set a pin as an output pin? You write pin mode. Okay, so pin mode is written pin in small letter, the M in capital letter, and the remaining letters in small letter. So make sure you are very case sensitive because your code will not work properly if you don't do this correctly. So pin mode, open to bracket. All right. So you want to do this. You want to do um the first pin 0, right? 0, comma output. Okay, so when we start talking about variables, we'll know how to make it easy. Should have declared a variable to hold 0, 1, 2, but let's just do it this way for now. Same thing you're doing for pin 1, you're setting it as an output, semicolon. Don't forget your semicolon. After each statement, always end with a semicolon. Okay, so 0, 1, and 2 outputs. The output is in capital. Take note of that. Don't put it in small. It's always in out. So we set pin 0, 1, 2 as an output pin, meaning that they cannot give out signal. All right. So the first thing we want to do is we want to turn on the red LED. We want to turn it on for just half a second and then turn it off. Then after that, immediately turn on the yellow LED for half a second and then turn it off. And then immediately this one turns off. We want to turn on the green LED for half a second and then turn it off. So that is what we want to do. So knowing what you want to do is a guidance to how you write your code. Okay. So when things start getting complicated, when we start doing big things, we might need to write a pseudocode or some sort of algorithm in English to prepare you on how to actually implement your code in the code editor. Okay, so now the red LED is 0, pin 0. So we want to manipulate pin 0. We want to write to pin 0. What are we writing to it? We want to write high or 1. Remember, high means that this pin should go high, meaning that the voltage on this pin should go high. How do you do that? Digital write. Digital write, the W is in capital, don't forget 0, high, close bracket, semicolon. Then after with that is, once that happens, this LED turns on, then we want to wait for half a second. How do you do that? Delay. Okay, delay for 500 milliseconds. Okay, 500 milliseconds means is 0.5 seconds. I explained that already. So once we hold on for 500 milliseconds, we want to turn off this same red LED. So I'll do digital write. So let me just copy it and paste here. Digital write 0, low. Okay, so now the next thing I want to do is to immediately, once this red LED goes off, the yellow LED should turn on. So what I want to do, digital write, yellow LED, which is connected to pin 1. So I'll change this 0 to 1. Hold on for 500 milliseconds again. All right. And then turn it off, which will mean yellow LED should go low. Okay. So immediately I do that, the green LED should turn on. Digital write, green LED, which is pin 2, should go on, which is I. Okay, wait for um 500 millisecond. Okay, then immediately it's after waiting for 500 millisecond, we want to turn it off. Turn what off? Turn pin 2 off, which is what? Which is low. And then after that, we want to wait for another 500 millisecond. Okay, So once you wait for 500 milliseconds, remember I told you this is a loop function. It's a function that repeats over and over again. So when your code runs from up to down, what happens is that your code will start running from up again in this loop function. So this function go over and over again. So it keeps on repeating. And what only stops it is you removing the power from the Arduino board or by detaching the USB from your computer. Okay, so it happens. So even if these LEDs are not connected here, this activity we just wrote, this code we just wrote will keep on happening at or to these pins. Okay, even if you take off the LED, bring it back, it'll still keep on working. Okay, so that's it. So our code is done. So now we can now run. So how do you run? Okay, so you can close and open this code area by just clicking on this code button. Okay, so click start simulation and then let's watch. Okay, so here it says there are some errors with my code. So let's see what it means. So this is unavoidable. We'll keep on seeing errors. Okay, so now let's see. It's in function void setup. This is setup. What is happening there? Output is not declared in this scope. Okay, output. I misspelled output. I didn't put the T here. And also, it's complaining about this line 13. Said, okay, I think I misspelled delay here. Okay, what else? And also, pin mode. I misspelled mode. Okay, so I believe those are good to go now. All right, so our program is working. The LEDs are working as we expect them to, or at least as we program them to do. So this is our traffic light system. So you can adjust the delay function to, this is how basically most of traffic light system works. They only have a time interval between each of the LEDs. Nothing much. That's just it. Yeah, we can change, we can have them to work after 1 second. We just have to change 500 to 1000. Okay. All right. So let's start. Okay. Now our code is working. You can now see the LEDs are switching after a second. Okay, so that's all. So once you do this, make sure you do this and then or all changes saved. It is saved already. All right, so now we want to see how to implement this on Wokwi. Okay, so I personally love working with Wokwi than Tinkercad, not for any reason, but because of its code editor. It has a colored code editor, and then it is um it makes me writing the code quite more simple. Unlike on Tinkercad, it has code completion and all of those stuffs. So just do what I do. Go to project, new project, go to Arduino, and then click on Arduino Uno Ref 3. So and then you have your thing here. So the same thing that we did there basically works here. Okay, so all you just need to do is to grab the LEDs. Once you grab the LED, you can change the color. You can see the colors here. Then do your wiring and all of that. And then let me just copy the code here. It's still the same thing. Let me copy the code here and then let me have it pasted here. Okay, so that's that. So resistors, let's grab the resistor. Good. Okay. So yeah, I would connect the same way I did over there. You can rotate components by just clicking on the rotate button. Okay, so let me grab more resistors here. There's no duplicates, sorry, more LEDs, more LEDs. Okay, so let's change this one, so this is red, let's change this to yellow, and then let's change this to green. Okay, so okay, So first things first, hook up the LEDs to the pins via the resistor. Okay, okay. Here goes here, here goes here, and then another resistor. Okay, here goes here. Here goes to pin 1. Yes. So now don't forget to change the value of the resistor. If you don't change the value, this is a 1 kilo ohm resistor. The LED will not be really bright. I think I should explain that in a moment. Okay. Change this to ohms and change this to 20 and you'll be good. Change this to ohm, change this to 220. Okay. And you'll be good. Another resistor. Then you take this. All right. Here. And then let's grab this to pin 2. Okay, so we have all of them changed. So now we now need to connect the negative wires to the ground pin. Yes, ground. Ground. Okay, so no time for changing colors here. Can change the colors if you want. Okay, so I have the code copied from Tinkercad and then pasted the code here, so it is still the same thing. So all you just need to do is to click on the play button and then it compiles the code and then start working. Can you see that? It's working. Red, yellow, green. So now let me tell you what happens when you have a very big resistor. Let me stop this for now. Oh, I didn't change this value. So let me tell you what happens if you have a resistor, if you use the wrong resistor or a very too big resistor for your project or for your circuit. So this is a kilo ohm. Kilo means thousand, right? So let me say I'm using 10,000 ohms. That means the resistor will be limiting the current flowing through this LED so much, and that will make the LED to be less bright. So let's see what happens in this case. So it is still working, but there is definitely a change in the level of brightness. You might not notice it, but let me make it bigger here. Let me use 100 kilo ohm resistor. Okay. Oh, traffic. Okay. Saving, 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 saving. Okay, so let's go. Okay. Okay, I'm not sure there is actually a realistic difference between the brightness, but in reality, when we are doing this physically, that's what happens. And we'll see that um, in our future class. But let's try and see if that happens in Tinkercad. So let me change this resistor to something like 1000, sorry, 10,000 ohms. And then let's play and see what happens. Okay. Can you see this red LED is not as bright? Not very bright. Okay, just study the brightness here and then let's change it to something very, very less. Let's change it to the normal one we used earlier and then let's start. Can you see this LED is brighter than it was before? Yes, so that's why. So do this on Tinkercad. You don't necessarily need to do it on Wokwi. I personally just like using Wokwi because come on, look at this. When writing your code, it helps you complete. So imagine you want to write digital right. Can you see? I don't need to write everything. But on Tinkercad, you have to write everything. I think that's good for you girls so that you can actually know because code completion has a way of making people lazy. So I love the way Tinkercad do it. For you girls, you have to use Tinkercad because there's no way to submit projects on Wokwi. So you have to use Tinkercad and write this exact same code. So if you don't, um, nobody will be copying and pasting this for you. You have to write it with your hands. Okay, it's better to write it and to copy and paste. So you can screenshot this place. Okay, and then go right. So that will be all.